Hi friends, welcome back. Last session we have seen the linear arrangement of buffers as a queue had the problem of showing that the queue is full in spite of memory being free. The main reason was the front as well as back indices were just moving ahead, and there was no chance of getting them back, and hence the space which was freed after removing the data from the queue, the space will remain free, and there was no chance of writing new data over it, and hence the queue uh, tail of the queue reaches the end of the queue, and there is no more space left to write at the end of the queue, and hence it says the queue is full. Any solution? Yes, of course, some way we need to make sure that once the back end of the queue comes to end of the memory allotted for the queue, then is it possible to somehow automatically get back to the first location? So if it is done so, then after 20th data, you get 21st data. After that, you get 22nd data. And then after 22nd data, the back will be now pointing to location number 1. And when 23rd data you wanted to add, so whenever you said add data 23, then it gets into location 1. And then back gets to the next location, that is 2. And this way it keeps on doing. If we can allow the front and back pointers to shift from the end of the memory to back to the beginning of the memory, then this can be easily taken up. And if you just carefully look at it, it just appears as if the last location is just before the first location, or the first location is just after the last location. That means some circular arrangement. Yeah, that's the circular queue we are talking of. So when we begin, the front and back are at the same place. So if front and back are same, which means the queue is empty. So let's beginning add data 1, then data 1 gets here, then B comes here, then when you say add data 2, then data 2 comes here, then B gets here, and then when you remove data 1, then data 1 is removed, and the F is now shifted to this. Now we have added data 1, then added data 2, then remove data 1, then you add data 3, then data 3 comes here. So that way you keep adding various data. Then we see what would happen. Then data 3, data 4, data 5, data 6, data 7, data 8, and 9, 10, 11, 12, 13, 14, 15, 16, 17, data 18. No, this was our location 1, and location 1 is free. So after data 18 is added, now this one is the back, and if 19th data comes in, then data 19 comes here, and then B is shifted here. So when B is shifted here, it means again F is equal to B. Now the situation is the stack, the queue is full. This can be done if you remove D2, then this space becomes free, then this is no more back. Now this becomes, sorry, this is no more front, so this becomes the front. So next time if you want to remove, then when you say remove, then D3 will come out, because the front index is showing D3. So D3 will come out, front will move one shift. So now we can see that these spaces which are freed are available for new writing. So the front and back indices keep rotating this way, and as long as the back is behind F, so there is space to write. So as long as B is behind F, there is space to write. And in the beginning, if F and B are equal, then it is say that it is empty. And as you move ahead, then as you keep adding new and new data, then it may come one point where all the places are full. That time the B earlier was showing the previous location, but after adding it is becoming equal. So that talks about the thing is full. So before F was B was less than F, and then B becomes equal to F, then it is full. And for empty, what would happen? As you remove D1, D2, D3 and all that, there will be some time when full comes here. So full was before, front was before back, and the next step, front becomes equal to back. That talks about the empty condition of the queue. So these are the possibilities. So one step before, B was less than F, the next step B equal to F, then the thing is full. And the other case, one step before, F is behind B, and after that operation, F is equal to B, so that talks about the emptiness. So that's about a circular queue. So we can make use of limited memory, limited size of buffer, and keep on using for unlimited number of data to be dumped onto this queue. Only condition to make sure that it doesn't overflow, so doesn't become full. So if you can make sure that the queue doesn't become full in this case, then this limited space queue can be used for unlimited number of operations. So that's the advantage of circular queue. Thank you.